Hi, everyone. I hope you enjoyed lunch, and I hope you found your way over here. I know it's quite circuitous over here, but I'm actually getting to the point where I can find this in under 8 minutes to get back to this lagoon view. First of all, for those of you I haven't met, I'm Chris Doring. I'm a member of the EarthRanger team leading the Gundi platform. That's less important than who I have to introduce today. I have the pleasure of introducing Christin Khan, and I'll just read this because it says it better than I can. She's a marine biologist and photographer in protected species branch of the NOAA's Northeast Fishery Science Center in Woods Hole, Massachusetts. And her current projects center around the conservation of the North Atlantic right whale and include aerial surveys aboard the NOAA Twin Otter airplane, which you'll see a photo of soon, analyzing social behavior, habitat modeling, outreach sign distribution, and the creation of facial recognition software for photo ID. So without further ado, Christin Khan.
Thank you so much. Thanks all for being here. Hope you guys are all enjoying the week so far. I'm thrilled to be here with you in Cape Town and excited to tell you all about how EarthRanger is doing a deep dive underwater in support of North Atlantic right whales. So it's really amazing to be here and so close to all the important conservation work done by the EarthRanger team. I'm reporting on work that's done quite a bit north of here, off the coast of the United States and Canada. So as Chris mentioned, I'm a biologist in the US with the National Oceanic and Atmospheric Administration, or NOAA for short. And I'm fortunate enough to work in Woods Hole, which is a tiny little village of scientific institutions devoted to the study of marine biology in the state of Massachusetts. My research focuses on the North Atlantic right whale, which is a large baleen whale. It reaches lengths of 55 feet or 17 meters and weighs 110,000 pounds or 50,000 kilograms. Some of you may be familiar with the southern right whale, which can be seen right off the coast here in Cape Town. Last time I was here for the Society for Marine Mammalogy conference in 2007, we took a local whale watch boat out in search of southern right whales, which was really exciting for me, spending my life studying their close relatives. And I was really shocked that the boat left the dock. The seas were so high that where I live in the US, the boat would not have gone. But leave the dock it did, and we bounced around wildly for a few hours, and we didn't really see any whales. But then we had lunch at a nearby restaurant overlooking the ocean, and I actually saw southern right whales right from my lunch table while sipping a glass of wine, which was pretty remarkable to me because we almost never see North Atlantic right whales from shore. And when we do, it's once in a great while in one particular location that's pretty remote. You have to hike a few miles out on the beach, but it's very unusual. And I certainly have never been sipping a glass of wine while one just strolled by. Both species, the southern right whale here and the North Atlantic right whale that I study, are really quite similar. However, southern right whales tend to be a little bit more robust, bigger, and healthier, as you can see from the 3 images on the left slide, which shows southern right whales from Argentina, Australia, and New Zealand. The North Atlantic right whales on the far right, they face quite a bit of challenges, which really impact their health and tend to result in them being a little more covered in scars and a bit skinnier. There's actually a third species as well that's closely related, the North Pacific right whale. And all 3 species are morphologically quite similar, but they're completely geographically isolated and don't interbreed. North Atlantic right whales are very well studied. Most of my career as a marine biologist has been spent flying aerial surveys, searching high and low offshore for North Atlantic right whales. We fly in a small aircraft, a NOAA Twin Otter, with 2 pilots up in the front and 3 scientists in the back. One of the scientists collects data using a laptop and GPS feed, and the other 2 spend the flight looking for whales out of an acrylic bubble window, one on each side of the plane, which offers a lovely view, but the seats are facing forward and the window is facing sideways. So you do this for 6 hours, which can leave you a little stiff after. We fly a set of track lines, searching for and photographing the right whales, gathering information to feed into our understanding of their abundance and distribution. And this plot of track lines from Whale Map shows aerial surveys over the course of about a month. Sort of each cluster of them represents 1 day's flight. And we target areas within reach that they're known to occur. We try to target known aggregations as much as possible, since the focus of much of our work is photo identification, which feeds into our models of the abundance of the species. When we find right whales, we photograph them from above to capture the distinctive callosity pattern on top of their heads. And this pattern can be used to recognize them as individuals. This is a very well-studied species. We know a lot about their life history, distribution, and behavior. For many of these whales, we actually know how old they are, who their mother is, how many calves they've had, where they like to hang out and eat. And we used to do this work via manual identification. Since the population is in decline and there aren't so many left anymore, a lot of folks can actually recognize many of the whales on site now. But I also ran a Kaggle data science competition a few years ago to create machine learning algorithms to recognize them as individual whales. And that work is now implemented in the WildMe Flukebook platform. And I know several folks in Africa use WildMe for the African Carnivores Project for photo ID. And there's probably other use cases here as well. We also conduct research on small boats, which allows close approaches for biopsy, prey sampling, and health assessments. You can see much more detail up close and personal on a boat than we do from the aircraft at 1,000 feet. And there are a variety of passive acoustic instruments that record whale vocalizations and help to inform distribution and monitor important areas, such as heavily trafficked shipping lanes. And I'm currently working to develop an innovative new method of monitoring whales using very high-resolution satellite imagery from space. It really has a lot of potential, particularly to reach areas far offshore that are too far to go from a boat or even from the plane. We have limited fuel endurance. But it is quite challenging. In order to automate the detection of whales from satellite imagery, first you need a training data set of examples of whales in the imagery. And as you can imagine, that's actually quite hard to achieve. We've been tasking satellite images over known aggregations of North Atlantic right whales, but the images are huge, and there may be no whales in any given image, or there may be one or two. So it's taking quite a lot of time to build up that training data set that will allow us to automate the process. But we do have a great active learning pipeline developed with the help of Microsoft AI for Good that's allowing us to annotate those images pretty quickly so we don't have to manually do it in ArcGIS. All of this whale detection information from all the different sources gets coalesced and displayed on tools like Whale Alert and Whale Map for mariner awareness. And we put up informational placards at marinas and boat ramps to increase awareness as well. All of this research and education enhances our understanding of North Atlantic right whales, and unfortunately, the results are rather discouraging. There are actually less than 350 North Atlantic right whales left, and less than 70 breeding females. And we're very concerned about the possibility of extinction. One of the major threats to their survival is entanglement in fishing gear. There have been 79 cases documented since 2017, which marks the beginning of what we call an unusual mortality event. And we know that not all entanglements are even documented, so this really represents a minimum. At this point, nearly every living North Atlantic right whale carries scars from fishing rope. When I first started flying aerial surveys in 2005, if a whale had a lot of scars on its tail, like this one in the picture here, we would make note of that and record it in the data. And these days, they all have scars like that, and we don't even take note of it anymore. There are extensive health assessments done in other ways, but in terms of, a way to recognize who's who from the plane, it's not really worth talking about anymore. North Atlantic right whales are also struck by vessels as they inhabit some of the busiest coastline in the world. There have been 18 cases of documented vessel strike since 2017. And NOAA is actually in the middle of new rules to slow down ships in an effort to make the ocean safer for whales. As you can imagine, this is a fairly contentious topic. Vessels aren't excited to have to slow down, and there's been a lot of pushback. Ocean warming is also causing distribution shifts to the prey of North Atlantic right whales and making it really harder for them to find adequate densities of prey to support calving. This is resulting in fewer calves born each year and whales moving into new areas in search of food, bringing them into ever-increasing conflict with fishing and shipping operations, particularly in the Gulf of St. Lawrence in Canada, where they've moved recently in search of food, and it's quite a busy and industrialized area. Finally, the human activity in our oceans in general really creates significant amounts of noise, much of which is stressful or disruptive to the day-to-day lives of North Atlantic right whales and other species. There was actually a really cool and fortuitous study done where just coincidentally, at the time of the 9/11 terrorist attacks, there were field biologists out collecting hormone and stress samples to measure cortisol levels and things from North Atlantic right whales. Well, on November 12th, the entire U.S. stopped. Everyone stayed home. No one went out that day, except for, as you can probably imagine, the biologists were not to be deterred from their study. And they went out and continued to collect these samples from the whales. No other ships on the water that day. Months later, when they started to analyze the results, they thought there was something wrong because they were so anomalous. Turns out, with no vessel presence nearby, other than that one little research boat, the stress levels of the North Atlantic right whales just plummeted from the normal baseline. And all of this really helps to explain why North Atlantic right whales are in poor condition compared to southern right whales, which by comparison tend to live in habitats less impacted by humans. In recent years, my work has become increasingly focused on preventing entanglement. It's a major cause of the right whale decline, and it's just heartbreaking to watch these animals swimming around with rope caught in their mouth or wrapped around their flippers, preventing them from feeding, socializing, and rearing young. So I've been supporting the development of on-demand fishing, also known as ropeless or buoyless fishing. And the concept is to replace the rope that typically connects a lobster or crab pot to a buoy at the surface, and instead of using a rope, release the trap with an acoustic signal that triggers either a pop-up buoy, an inflatable lift bag, or a buoyant spool of rope. By getting the rope out of the water, we decrease the chances of a whale becoming entangled in it. On-demand fishing gear could allow both whales and fisheries to thrive. And the gear manufacturers have made amazing progress on the hardware with solutions that really work to catch lobster and snow crab without a rope and to retrieve those traps with acoustic signals. The NOAA Northeast Fisheries Science Center has a gear lending library that helps fishermen to engage in the process of testing and trialing the gear at sea, which has been just critical to making the relevant improvements. One of the challenges was how to know where the gear was located on the seafloor without that surface buoy to mark the location. And to address this challenge, ropeless gear manufacturers set to work building apps and databases. The trouble was that their systems were all proprietary, so the fishermen could only see gear from other fishermen nearby if they also were using the same system. We needed a way to blend these data streams from different sources into a common framework. And of course, this need to blend data from all the different sources is what led us to reach out to EarthRanger. And you all already know how fabulously talented and hardworking they all are. They're experts at blending data from many different sources, and they've been able to bring together a stunning array of data feeds into one common framework for conservation management. I should also mention that this slide is probably a year old, so Chris could probably tell you there's more integrations than I've got here. The EarthRanger team has been able to take these proprietary systems from different gear manufacturers that had previously been operationally siloed and build custom APIs to coalesce these data feeds into one common framework. Last summer, we took out the gear systems from 3 different manufacturers on 2 different vessels, and we tested them out on the water off the coast of Massachusetts. The testing was successful, and gear positions were displayed on EarthRanger from all the different systems, which was a really exciting proof of concept for how this would all work. Since that time, the gear integrations continue to be tested as part of the ongoing work by the NOAA gear team and the manufacturers. It was so exciting that it was even highlighted during the plenary speech given by Dr. Michael Moore at the Society for Marine Mammalogy as a ray of hope that we were really making meaningful progress towards preventing extinction. But let me tell you a little bit about each of the 5 different systems we currently have integrated. EdgeTech, which produces the 5112 ropeless fishing system. It's a release cage with a line and flotation cover with an integrated, rugged acoustic release and transponder. They also make a bleat deck box, a transducer, and the EdgeTech trap tracker application. Smelts has developed the line-free lobster lift raft, which replaces the vertical line with an inflatable lift bag technology. Their system is designed to be flexible and adaptable with a variety of different acoustic release manufacturers integrated, including EdgeTech and Teledyne. Blue Ocean Gear makes smart buoys that transmit data via satellite and radio in real time once the buoy reaches the surface. So this gear is being used frequently as a backup system as well and to help find the gear once it gets to the surface. Assured produces the MOBI, or modular ocean-based instrument, which coils and contains a fisher's line on the seafloor until they return to collect the gear. And Devocean is making a buoy and coiled spool of rope attached directly to the crab pot. And not only has EarthRanger seamlessly integrated the fishing gear from these 5 different companies, but they've also added some custom functionality to fit this use case. Using traditional surface buoys, other folks out on the water can see when there is gear nearby, even though the actual trap is underwater, because the position in the water column is marked with colorful buoys. To replicate this system with virtual buoy positions, the EarthRanger team had to create a permissions-based system based on the user's geographic position so that the system would only display gear nearby. We currently have this set to a default of 5 nautical miles from the vessel location. And in order to avoid the possibility of spoofing the system, there are some vessel speed rules programmed in that trigger an alert if the vessel appears to be moving at an unrealistic speed. That behavior temporarily suspends the user account. Fishermen jealously guard the locations of their fishing gear, and they're very concerned about someone having unfair access to this information. We also implemented right whale seasonal management area polygons for increased awareness of areas that right whales are known to frequent. These are seasonally predictable areas where whales are known to congregate, and they have associated vessel speed regulations, somewhat similar to the protected areas on land. Although similar to your challenges on land, the right whales do not always stay in their boxes. You may remember the distribution range I showed you earlier. Right whales travel from the coast of Florida all the way up into the Gulf of St. Lawrence in Canada, with occasional sightings even as far north as Greenland and Iceland. It reminds me of some of the distribution maps I've seen of elephants and other species this week, who also don't seem to like to stay put in their safe little boxes. EarthRanger has also added trawl lines so that instead of just points on the map displaying the different pots of gear, which could be confusing to the fishermen, there's now a line that connects the dots, since this more accurately represents what's happening under the seafloor. There are several challenges that still need to be addressed for this all to work smoothly. We need to do some additional integrations and bring in a few more data feeds. Interoperable acoustics. Currently, we are blending data feeds from surface-marked GPS units. The point is marked right on the vessel before it's thrown over the side. And as you can imagine, it doesn't land exactly in that same location. So the best way to get fast and accurate gear positions will be from acoustics, particularly in areas of high density fishing. All of these acoustic systems also really need to be interoperable so that any vessel can acoustically detect any piece of gear. This is especially critical for dealing with any gear that is moved from the original deployment location, and gear is moved both by storms and by other fishermen accidentally. We're hosting a workshop to begin to address this challenge in a few weeks. And finally, we're beginning to look into options for how to get this gear displayed on chart plotters, as we know many fishermen would find that more convenient than opening a website or an app. And the goal ultimately is to move the deployment of on-demand fishing from an experimental research effort under an exempted fishing permit, or EFP, into a regulatory framework. And ultimately, of course, the goal is to really reduce or eliminate entanglement in fishing gear. So thank you all so much for taking the time to learn about these initiatives and for all of your own work that's gone into the development of EarthRanger and wildlife conservation. I'm so grateful to the whole EarthRanger team for embarking with the U.S. government on this public-private partnership in support of right whale conservation. And I really just can't say enough about how amazing they all are. And I look forward to chatting with you all throughout the workshop, or feel free to shoot me an email. And I can take any questions that you may have now.
Microphone.
Thank you. Thanks for the presentation. I was just wondering if you still find new adult individuals on your aerial surveys or when you're surveying.
I'm sorry, can you repeat that one more time with the mic a little closer?
Oh, sorry. Do you still find new individuals, like adults, sometimes?
Yeah, not really, or it's extremely rare. This population is actually, we recite 90% of all living individuals every year. And, even if you're not seen in 1 year, but you're seen the year before and after, that helps to capture it. So it's pretty rare that new individuals are added to the catalog. It does happen sometimes, and usually in those cases, it's because the whale has been sighted several times over the years, but for whatever reason, it's been challenging to match. It looks a lot like another whale, or the best way that we track these animals is if they're seen on the calving grounds with their mother, then we know who they are and who their mother is. But at that point, their callosity is not very well developed, that if you then don't see that whale for another 5 years, you're not going to be able to make the link back. So it's best when we see it with its mother, and then we see it again when it's like 9 or 10 months old and it's starting to develop, and then we can kind of trace that history. But in some cases, we don't see the whale for another few years. It then pops up as this mysterious young juvenile who we don't know who it is. And then sometimes years later, they're able to collect a biopsy sample of that adult and trace it back to the mother, or a biopsy sample of it as a calf. So it happens occasionally, but it's pretty rare. The whales are pretty well known, and most of them tend to hang out in the same spots that the biologists do every year. There is some sort of small percentage of the population that tends to avoid us or likes to hang out places where we don't go. There's one whale in particular that has been seen several times in Iceland, which we almost never even look in Iceland. And when we do, we almost never find whales there. But she's been seen twice in Iceland, and we saw her actually in Cape Cod Bay a few years ago, which was quite an exciting day. She randomly showed up in Cape Cod Bay with a calf, which was the first time she'd ever been seen here. But they really do some crazy things. One showed up off the coast of Spain a few years ago. There used to really be a population off the coast of Europe, which was unfortunately extirpated. So there isn't really a remnant population over there today. The ones that we occasionally see in Europe are our same East Coast population.
Thank you.
Any other thoughts or questions?
Sure. Oh, thank you, Zee.
I can just ask.
Okay.
Well, how do you see new offshore wind factoring into right whale conservation?
The question was about offshore wind, and speaking Personally, honestly, I feel like entanglement and vessel strike are such huge risks to the survival of the species that I don't tend to focus a lot on offshore wind, but there are some reasons to be concerned. In particular, they're putting some offshore wind development in Nantucket Sound, which is just south of Massachusetts in an area known to be frequented by right whales who are feeding there. And we know that the offshore wind development will change the wind distribution and circulation patterns in that area. And we don't really know what that means. Do you have any follow-ups to that? Are you good?
No.
You look like you were ready to say something else.
Thanks. The technologies look really exciting, but what's the cost implications and can it be rolled out globally, I guess, because it's not just a problem for your population?
Yeah. I don't know where to start with that. Aerial surveys, satellite images, on-demand fishing gear. Do you want me to talk about all of those? The aerial surveys are quite expensive. They are, however, our main tool for monitoring this population. It is a pretty well-funded species off the coast of the U.S. It's charismatic. It's, everyone loves whales, and they're plunging towards extinction. So we have a lot of public engagement. And the aerial surveys are really our best research tool for effective monitoring at this moment in time. The different tools have different pros and cons. The satellite imagery is probably that most people are, that makes satellite imagery completely unaffordable. We have fortunate access to large volumes of the imagery, so that helps. The on-demand fishing gear technology, it is really expensive. I mean, it's on the order of $5,000 or $10,000 to get up and running with this stuff. And we hope that the cost will come down in a few different ways. One, this technology is brand new and made in niche little batch amounts. And if it expands more rapidly, we get more competition in the market, we start to really mass produce, we expect costs to come down. And a lot of the manufacturers are really focusing on trying to make that gear less expensive because they know, people aren't just going to pay $5,000 for every single trap. Some fisheries are willing to bear that cost right now, particularly the snow crab fishery in the Gulf of St. Lawrence. It's a very lucrative fishery, and it's really costly for them to be closed out of an area because of right whale presence. So that they'd be willing to pay a lot to get back in and to continue to harvest their catch. The U.S. recently passed this Inflation Reduction Act, which is So at this point in time, the U.S. government is subsidizing heavily the cost of this gear to get folks into the market. But ultimately, it may be a cost or a decision per fisherman. Do you want to just not fish in this area at this time because there are too many right whales there, or is it worth it for you to adopt this new technology so you can get in there? But we hope the cost will come down because, the dream would be for this to just be the norm and to be used around the world because, as we all know, bycatch is just a huge problem for every marine mammal species all around the world. And it would be amazing if this could just be the new norm. I don't know. I continue to hope, but it's a heavy lift to get there, I think.
What's the mortality rate per year? The mortality rate per year would be interesting. Yeah.
Yeah, it varies per year. Let me see if I think I have a slide that shows that better than what I can explain. So the population until around 2017 was creeping up slowly. We had 300 whales in the 80s, and sorry. There's an excellent infographic on this topic that I apparently didn't put in my slide deck. So we had about 300 or so whales in the 80s. The population was slowly creeping up. We, at the time, celebrated the crossing of the 500 mark. We learned a year or so later that that was probably a little unrealistic of us. And then since about 2010, the population has come from 500 down to 350. And mortality does vary considerably annually. We had one year where we found over 30 carcasses, and we know that we only find maybe half of them if we're lucky. And the calving rates also vary considerably. We've had, I think the most we've ever documented in a year is 31 new babies, and we had one year where we didn't see a single one.
So what do you think has caused that switch? Because I'd imagine rope fishing has been around since.
Yeah. There's a couple of things. One is that the rope that long trawls. And so I think the gear itself is much more dangerous. And then the other big change has been climate change. The Gulf of Maine is actually warming faster than any ocean in the world. And that shift in temperature has changed the distribution of their prey, which is they feed on these, they're called copepods. They're little tiny, almost like a shrimp, but they're about the size of a grain of rice. And so they actually feed in volume on clouds of these copepods in the water. And due to the changing circulation patterns and warming in the Gulf of Maine, copepod distribution has shifted. And in particular, feeding aggregations have moved into the Gulf of St. Lawrence in Canada, which is an extremely industrialized port. So that probably has a lot to do with the recent amplifying of the crisis. Also, food appears to be getting more and more scarce. Whales are having to go further and further in search of it. It used to be that a female would give birth to a new calf every 3 years, and that interval is more like 5 to 7 years now. Combination between difficulty finding enough food to support a pregnancy, and anytime a right whale gets entangled in fishing gear, even if she lives through it, she's not going to produce a calf for a while she recovers. Which is what we're using. And that's enough to clearly see you have a whale. It's a little bit challenging even to identify species. North Atlantic right whales, we're lucky they have these weird white bits on their heads. I should tell you guys about that actually, because it's weird and cool. It's almost analogous to like a rhino horn or something. It's made out of keratin and it's flat. When the calves are born, you can actually see maybe a little bit here. It's not really so white. It's just like a raised patch of skin that's dark. And the white is actually little tiny crabs that we call whale lice that form that pattern on them. So, when you see a dead one on the beach, there's little tiny crabs crawling all over there, which is so weird and fascinating. But this is actually the pattern that we use to recognize individuals. And it's also a good species indicator. So from on a good day where, particularly if it's a light colored rope, sometimes even from the air, we'll be back reviewing the photos in the office the next day and be like, oh, that's a rope that we didn't catch from the plane. But for the most part, we can usually see it in the plane if it's, often it's like draped across the whale's back, or even, this kind of thing would make us nervous in the plane where we'd be like, wait a minute, what's that? That's, in this case, just water. But sometimes they're quite cryptic. Sometimes they're caught inside the baleen and they're difficult to see and evaluate. So often these entanglements are detected from an aircraft. Often we're way offshore and it's 4 p.m. and it's about to get dark and it's getting windy, and all we do is take pictures of it and that's it. And then everyone kind of keeps an eye out. We might try to go back to the same area the next day in hopes we get lucky. If we see it and it's more like earlier in the day and the winds are good and we're not so far from shore, often we can actually get a rescue team with a boat out there to try to disentangle it, which is really dangerous, really stressful. It's dangerous for the whales and the humans. It's stressful. It is often successful, but, it'd be a whole lot better to just not get the rope on these whales in the first place. Yeah, the question was about sedation of whales. And, I'm sure you all know it's actually quite dangerous and challenging to get the dosage right with a lot of land animals. And whales are voluntary breathers. They don't stay at the surface and breathe automatically. It's a choice. So it's very dangerous. If you really properly put them to sleep, they would drown. And so for those reasons, and for the fact that it's such an endangered population, in general, we have not done that. There was one case in which this was done because the whale, I just can't even describe how awful it looked. It was clearly going to die. There was no hope this whale was going to shed that gear on its own. And it was like, either we get the rope off or it's just not going to make it. And in that particular case, they decided it was worth the risk to try to sedate it because we didn't really feel like we had anything to lose. And they did successfully get it to slow down enough to let them approach and cut that whale off. So in that sense, it was successful. They documented it afterwards, so the sedation attempt didn't kill it, but ultimately it did die of its wounds and did not survive the health impact to that. But so it's been done once, and they learned a lot from that. eggs or something. Yeah. So yes, there have been several attempts over the years to track individual animals. It is challenging primarily because seawater doesn't play well with electronics. And North Atlantic right whales are very social, actually, and they're very tactile. They occasionally feed on the seafloor. They rub against the mud on the bottom. They actually roll and bump and crash around with each other. So any kind of surface attachment tends to get knocked off. Early attempts in the 80s were, sort of the equivalent of drilling a barbed stake into the animals, which had significant health impacts. And some of the whales to this day have big divot scars from that kind of left a bad taste in everyone's mouth and caused a lot of people to be firmly against any kind of attachment to the whales. In recent years, we've started to try again with some more modern tags, and there are both deep implantable tags, which are more advanced and less invasive and harmful, and do tend to stay on for a little bit longer. And then we also have these, they call them limpet tags, which are a suction cup tag, and so those can be mounted with a pole. You just sort of slap it on the back of the whale, and those So that tag technology is advancing, and people are working on it. There's kind of this, because of all the impacts to fishing gear and vessel traffic, there's a lot of rage and a lot of unrealistic, well, I've never even seen a right whale. Why should I have to change my behavior? Which, no doubt, lots of people have never seen a right whale. There's 350 of them along the whole East Coast. So it's not surprising that you've grown up in Maine your entire life, you've fished there your whole life, and you've never seen a right whale. But we know from the right whale perspective, they see that rope every day. So it's kind of a challenge in the human-wildlife conflict to manage that. And a lot of those folks would like to see us track every single right whale all the time. There's only 350 of them. Let's just know where they all are all the time, and we'll get our gear out of here when they're here, and when they're not here, we won't. So there's a lot of desire for that. But it's just not realistic. We don't actually have the ability to attach a tag that stays on for more than a couple months. And so we're not going to relocate every 350 whale every 2 months to reattach a tag. It's just not possible at this moment in time. But a lot of people would obviously like to see that done.
Okay, Christin, we only have about 35 more minutes left for questions. Actually, we are out of time, but I would encourage you to find Christin today too, because I like being a naive software engineer with exposure to all of you. Though it's there's so much overlap, but there's nuance inside that overlap, and I think it's awesome that you're getting to meet Christin and she's getting to meet you, learn about the challenges you have, and talk through them.
Yeah, it has been really fun on the surface of things. I feel like I don't know anything about your work, but then every time I talk to someone at this conference, we have this cool little area of overlap where we're both trying to do the same thing in different ways. So it's been great to meet you all, and thanks for coming.